what kind of triangles, you guys, do we use the Pythagorean theorem with? Yeah, okay. Only right triangles. All right, that's it. Only right triangles. That's what Pythagorean theorem does for us. So a squared plus b squared equals c squared. It's really important that you know that c has to be the hypotenuse. Okay, no matter what, c is the hypotenuse. So a and b are the legs, and c is the hypotenuse. How do we know which side is the hypotenuse? Raise your hand if you know how to tell. Bree. Very good. It is across from the right angle. It's also always the longest side. Okay? All right. So let's try one. Use the Pythagorean theorem to find side A. By the way, this should have that little box right there to show it's a right triangle, or else we couldn't do this problem. Okay? So a squared plus b squared equals c squared. Since you guys are so good at this, I'm assuming you know the formula. You don't have to write it down every time, but you need to show the substitution step, okay? So very important that we know which side is C. So Claire, which side is C? 9, okay? C has to be 9. A and B can be either one. I'm going to leave this as A since it's already labeled A, and I'm going to make this side B. So A squared plus B squared equals 9 squared. So I plugged in 5, and I plugged in 9. So again, you can start here, but you do need to show this step. So now I have a squared plus 25 equals 81. We actually are not going to use calculators on this. We are going to leave it in simplified radical form, all right? So subtract 25 from both sides. What's 81 minus 25, you guys?
56.
Thank you. Okay, and to get the a by itself right here, we square root. That undoes the square. And now I need to simplify. So I have a equals the square root of 56. Only sometimes they simplify, right? In order to simplify, we're looking for these really special numbers. 4, 9, what else? 16, 25, 6 squared. No, okay, right? Like all those numbers, right? That's what you want to pull out is any kind of perfect square number. So what goes into 56? Any of those numbers go into 56 evenly? Yes, Sam. Yeah, 4 times 14 is 56, all right? What is the square root of 4? 2. So we can take out a 2 because the square root of 4 is 2. And the 14 stays inside. Does 14 have any perfect square numbers inside of it? No, because 14 is 2 times 7. 2 is not a perfect square number, and 7 is not a perfect square number. So this is how I want your answer. Simplified radicals. Okay? If you're not sure how to do that, you can always ask me again, because we didn't really get a lot of practice. I'm hoping you kind of remember that. All right. Now we have another kind of problem here. Use the Pythagorean theorem to find the distance between 5, 3 and -2, -3. So you guys probably did distance formula at some point last year. We will do that again, but for now we're actually just using the Pythagorean theorem to find the distance between the 2 points. So if you picture 2 points on a grid, and I'm not going to draw the grid, okay, I actually want to know what is the distance between here. We're not doing the slope, right? Slope is the tilt of the line. We're doing the actual distance in between. You want to draw on that right triangle if you were actually drawing this, but you don't have to, all right? And what you're looking at is actually the Pythagorean theorem. If I did a squared plus b squared equals c squared, we could find that length, okay? What I need to find is the distance from here to here. This is actually the distance between the y values. If you're going up and down on the grid, that's the distance between the y's. So how far is it from -3 to +3? That is a distance of what? It's a distance of 6, okay? -3 to 0 is a distance of 3, and 0 to 3 is a distance of 3. So we actually have 6 squared plus. Now we find the distance between the x's. So if I were to go from here to here, that's the distance between the x's, because if you're going across like that, okay? How far is it from 5 to -2? 7. Okay? So we have the change in y and the change in x, so we have the distance between them, a squared plus b squared equals c squared. Okay, so 36 plus 49 equals c squared. What is that, 85? Okay? Square root both sides. And I want to know, are there any perfect square numbers inside of 85? So what I do is usually, well, I know 5 goes into that. How many times 5 go into that, you guys? Okay. 17 is prime, 5 is prime. There are no lucky numbers in there to simplify it. So you can leave it as the square root of 85. Live. Oh, you can. I won't fault you for that. If you like that. This is more confusing for you guys? Yeah. Really? Look how easy this is. What's the distance from here to here? 7. How do you not know? 5 to negative 2? What? 5 minus negative 2. Yeah, think of it like that. Subtract them. You could subtract in either order, but then you want the absolute value because you're doing a distance. So you could even do negative 3 minus 3 and negative 2 minus 5. But then make it positive because you're doing a distance. Or if you want to plug them in negative, you could, but then square the negatives. You know what I'm saying? So let's try it. Maybe I should just make up another one because you guys are like, what? All right, let's do like 2, 3, negative 6, 10. I don't know. Making that up, okay? So all we do, I want to know the distance from here to here. So if you want to subtract them, fine. Go in the same order. So 2 minus negative 6, if you want to think of it like that, that is a distance of 8. Okay, plus, now we're going from here to here, subtract, right? 3 minus 10. Okay, if you want to plug in negative 7, you can, because you're going to square it anyways, right? So it's going to become positive. So the distance would be 64 plus 49. What is that? 113. Square root both sides. Okay? Makes sense, you guys? So you're really just subtracting.